So I'll revise. So now, what is the Kubernetes is? Kubernetes is a container orchestration kind of tool which we are going to control multiple containers, and we can automatically create, delete, scale down, restart. All those we can manage from the Kubernetes. And the Kubernetes name is came from the Greek, which is the meaning of governor, pilot, or helmsman, who is going to control the ship. In the same way, here we have the containers, and all those are going to be controlled. And Google internally has used the Kubernetes, but they want to give like a contribution to the public or companies. That is the reason they made it as an open source, and they denoted this project like a cloud native compute foundation. So that's open native kind of computing foundation. It's an open source. Most of them are managed by them. Okay, even Linux also is a project with this. Then what is the advantage is the great community support is available. Even Google also is supporting for that. That means the recent changes, all those updates, everything also Google also is providing. And even for the cloud native kind of services also Amazon, all these also is going to use. And like the logo also, seven spikes we have, which represents seven engineers from the Google. And say Docker Swarm in the backend is using uh, Docker only as a Docker engine, but in the Kubernetes it supports multiple runtimes. So we have the container D, CRIO, then we have the Docker we have. Okay, so but Docker directly they're not supporting through the container D itself, and even gvisor, Firecracker. Okay, there are a lot of container runtimes are there. So we have learned only Docker, but it's not only Docker is the containerization solution. We have a lot of container solutions. We have, say, suppose if we go for hypervisor, AWS is using GenSource, Azure is using Hyper-V, or Google is using GKE, vCloud is using VMware. Like this, Kubernetes also supports multiple container environments. It's supporting multiple container environments. It is supporting. Okay, so previously, like Google has used with the name of Borg or Omega, but they kept the name as Kubernetes. And one of the thing what people will ask us is the Kubernetes versus Docker Swarm. Kubernetes is a little complex and suits for the large scale applications, whereas Docker Swarm is for for the small scale applications we are going to use. Okay, and automatic scaling, more powerful scaling features. Everything is with the Docker Swarm also, but not at the production level. Not at the production level, networking wise, load balancing, storage, fault tolerance. Everything is very powerful with the Kubernetes. With the Docker Swarm, those need to be proven. And huge ecosystem of products are available, and great community support also is available for the Kubernetes. Whereas for the Docker, only Docker itself need to support. The ecosystem is very big. Okay, and you are very simple. You have your application is large scale, and in the future is going to be highly scalable, enterprise level. More security is required. We want multi-cloud kind of support. Then choose Kubernetes. It's a very small team, and in the future also it won't scale up that much. Okay, and very simple kind of team we want to maintain. Then better to go for Docker Swarm. Okay, so it depends upon this. Or if you don't want to use Docker Swarm, in the AWS, we have a similar solution called as ECS also, Elastic Container Service. Okay, but for the large scale applications and say very huge workloads we are going to get, complex microservices we have, then better to go for
Kubernetes.
Kubernetes. Okay, so mostly like large e-commerce portals, OTT, banking solutions. Today, most of them are running on the Kubernetes itself, and it supports multi-cloud kind of cloud native supports, and even AI, ML kind of integrations also can be done. Okay, so whereas Docker Swarm is used by small startups, okay, say internal tools, or I want to give prototype or POC kind of things, or maybe dev QA environments, lightweight clusters. There we are using Docker Swarm. Okay, so based on these factors, depends upon your application. So maybe in the future it's going to scale up. Say I'll tell one example. Say now we have a Geo Hotstar is there. Like Geo Hotstar recently came, maybe in the last 3 4 years itself. But Reliance, no, they're going to acquire IPL kind of thing, all the cricket. That's the reason they chosen the Kubernetes itself or their architecture in the back end, because they know they're going to get some crores of users as their client base. But a new OTT company came. There is no like guarantee they'll get some crores of users. That's maintaining Kubernetes is maybe complex for them. At that moment, we can suggest to go for Docker Swarm or ECS kind of environments. We can suggest. Okay, small applications better to go for Docker Swarm because it's easy to manage, whereas Kubernetes is little complex to manage it. So most of the applications previously, those are monolithic applications, are now migrating to microservices today in the market. Okay, so now in the container orchestration market, Kubernetes is a leader. Okay, so there is no doubt about this. So hence, even if the market is down, why we are getting the like placements, calls, all this is the Kubernetes is also is the vital role. These I have identified at 2016, 2017 itself. So from there onwards, we have added Kubernetes in the DevOps engineer profiles. That is the reason with us, lot of engineers also got the success. Okay, but at that moment, the expectations are very low. But today, the market expectations are very high on the Kubernetes. And there are some millions of engineers who have vast expertise on Kubernetes. The same expectations they're expecting from us also. Hence, whatever the expertise you will get on the Kubernetes, that much success we are going to get in the job. Okay, so that's keep more efforts. All your efforts keep on the Kubernetes. Okay. So competitors we have is Docker Swarm, nowhere related. Then we have Nomad from the HashiCorp. Then we have Red Hat OpenShift. Okay. So then ECS or Azure Container Instances. So these kind of things are there, but nowhere competition to Kubernetes. Only some contribution, so competition is coming from OpenShift only. Only the from the OpenShift only we are getting the competition. Okay. Then EKS, AKS already we discussed this, GKE, and even IBM having we have VMware Tanju is there, SUSE Rancher, OKE engine is there. So we'll compare the differences. All are managed services itself, but there are some differences between them also we'll discuss. So even in the AWS, Azure, GCP also, we have the managed services. If you know the Kubernetes, any of that we can manage. Either that's from the EKS, AKS, GKE, or Tanju, or on-premises. Anything we can manage. Okay. Then coming to the Kubernetes architecture, the Kubernetes architecture having a master and worker kind of thing. So which is called as control plane is the master we are calling. Data plane is the worker nodes, or maybe master and node kind of thing. In the master, we have the control plane and we have the data plane. Very long back, say Kubernetes is using the one term called minions. Okay, so what is the meaning of minions? Are those worker nodes are called as minions, but now they're not using the minions. But one of the popular interview question, what is the meaning of minions? But as of now, no one is using the term called minion. But what is the meaning of minion is it's a worker node. Okay, so now the master component itself we are calling as control plane, and the worker node is called as data plane we have. And in the control plane kind of architecture, so we have like API server, we have the main component is API server. Okay, so what is the purpose of the API server is, like here we are going to manage those APIs if the user type the command, normally all these days we use Docker, right? Say Docker pull, Docker run. When we run these commands, Docker CLI will communicate with Docker daemon itself, or the API itself is going to communicate. Now in the Kubernetes, that command line tool is kubectl. Means what is the tool we are using? Kubectl. Whenever the user run the kubectl kind of command, it is going to use Kubernetes wise Cube API server
Yes.
it is going to hit. Cube
API server
API
uh,
server it is going to hit.
hit.
Okay, that API server will take the request. That means from the front phase of the Kubernetes cluster is API server. It's not only from the kubectl, like maybe from the third-party tools or from the GUI, from the dashboard, even in the AWS also. We have the AWS HDK we have or CDK we have. That is the front phase. Even if you hit from the console, CLI, third-party tools, everything from the Kubernetes wise, who is going to take that request is API server. Here we are going to perform authentication, authorizations, checking the resources, all those. Then here etcd is a NoSQL kind of database. All the meta information regarding the Kubernetes cluster is going to store in etcd. Okay, so what is the concept of etcd is all the meta information is going to be stored. Okay, so what is that meaning is like uh, if you have a student project, all the student information is going to store in the database or not? Can you tell what type of details are going to store in the project? So which type of projects are going to store in, if you have a student project, which type of details are going to store?
Name,
The student
class,
details, student, that is called as meta
student name,
information.
class.
Student meta information
Yes.
is going to store.
Uh,
This is also etcd is not a relational database. Okay, so this is okay. So what this is like here we are going to store that distributed key
Key
value store
value.
we are going to keep. Okay, so it's a distributed key value store is going to store it, and in that we are going to store all the values. Okay, then objects like whatever the nodes we have, resources what we have created, secrets, config map, events, all these are going to be stored. And that algorithm is going to use a raft kind of algorithm. It is using for the master and the slave kind of thing. Etcd level also will have that. But as of now, in the data plane, sorry, in the control plane itself, we are keeping etcd. If someone asks about etcd, what we need to tell is etcd is like a key value store database, which is storing all the meta information about the Kubernetes clusters. And if you want to take the backup of the Kubernetes cluster also, the very important component is, which is the very important component,
TCD.
etcd is the very important component we need to take the backup. Okay, so then we have the controller manager. What is the exact set? Say suppose what are the nodes we have, how many nodes it need to maintain, how many replicas it need to maintain, how many deployments, updates, rollbacks, jobs to run, endpoints on the service level. All these are going to be controlled by the controller. Say suppose I have given 10 replicas need to run. Then like controller is we have one component called replica set. That component will make sure always 10 parts are running or not. So who is going to control those?
Controller.
Controller will manage. Okay. Then we have one more component. Scheduler would be there. So
Scheduler.
scheduler is going to decide, okay, on which node the scheduler. Say suppose here we have the cube controller. Cube controller will control the desired state and actual state of the components. Then scheduler will decide on which node the pods need to run. What is that pods also? Just like containers we have, here we are calling as the pods. Okay. So then if you are using any of the cloud, so we need to use the cloud storage, cloud load balancers, cloud authentication like IAM kind of services. All these also can be controlled by the cloud controller manager. If you have on-premises, it's not required cloud controller manager. But here what it required is, like in the cloud-wise, we required cloud controller manager also. So here we have 5 components. Can you revise once? So it's very, very
API
important.
server,
Like
scheduler,
Kubernetes architecture
controller.
is like master and worker node kind of architecture, or we have control plane or data plane. In the control plane, we have API server. API server is the front end for the Kubernetes cluster. Then we have etcd, which stores all the key value data is going to
Store
store.
database.
Controller will check whether the actual state and desired state is there or not. If that not met, then what are the actions need to be performed. Then we have a scheduler will
Will
decide
create.
on which nodes the pods need to run. Then we have the cloud controller manager. Okay, to integrate with the cloud provider APIs, we are going to use. Then we have the data plane components or worker node components we have. In the worker node components, like we have the kubelet. The
Kubernetes.
kubelet is one of the agent service that need to report to the manager. So this should be running on the kubelet. If the kubelet is not running, okay, so then manager will assume, okay, that node is not working.
Work.
If that is not running, meaning is that is not working like that. If the
Means
manager is not working,
API server is given the request.
API server will give the, say suppose with the scheduler decision, API server will tell like what are the jobs it need to run, but the jobs whatever is running on the node side also is going to be verified by, again, reports to API server itself. That means master side API server, agent side kubelet, both should be communicating. Both should be communicating. Okay, this will reports like what's happening and will take the instructions from, from the from the API server. From the API server, it's going to check. And like we have kube proxy is there. One more is kube proxy, like to expose the services outside from the nodes. Okay, so he is going to use. So that means to expose the nodes, all these we are going to use kube proxy. This is one of the network service. Okay, it's going to provide the network service. Okay, then one more container runtime. Any of the one container runtime is mandatory. Kubernetes supports multiple container runtimes. Okay, so that's maybe container D, CRIO, gvisor, Firecracker. Okay, so these Docker directly not supporting. Through Docker also in the backend it uses the container D itself. Okay, so that's like we are going to use. Say on the agent side, we have 3 components. What are those?
Kubelet, kubeproxy,
Yeah.
pods.
So come again.
Kubelet,
Yeah.
kubeproxy, pods.
Yeah. Master side.
API server, scheduler, controller, etcd.
Like we need to explain also these all the components everyone need to explain. Then on top of the containers, say suppose I'll tell one example. Say we have normally in the VM virtualization we'll call VMs. Okay, but in the AWS that VM we are calling as the VM we are calling as we are calling as an instance. We are calling as an
Instance.
we are calling as an instance, right? Okay, so in the same way, that here we don't call as a container, we don't call. Okay, so in the Kubernetes environment, we are calling as pod, we are calling. Okay, the what is the pod is also after explaining those objects, the next interview people will ask us is what exactly the pod, what exactly the pod. Okay, so that's we should able to explain the parts we need to explain. Okay, so then command line, what is the command line tool is kubectl. Most of the administration, like in the Docker, the command line tool we have used is Docker. So Docker we are using. Okay, so here the command line tool we are using is kubectl we are using, and for the administration wise we use kubeadm.
kubeadm.
Bootstrapping purpose we are
Bootstrapping.
using kubeadm we are going to use. And if someone type that command, how it's going to communicate also we'll discuss. And namespace is also important. We have lot of resources we have. Okay, but today we'll discuss the pod, that architecture components, that pod. Okay, Docker Swarm versus Kubernetes. So these three are the mandatory interview questions. Everyone need to prepare on that. Okay, so we'll discuss what exactly the pod. Hello? Yeah. So normally the parts are called as containers, but in a pod is a the lowest level of object is managed is pod. That means the next objects are higher than pods only. Okay, so that's the pods. What is going to happen is pod is an encapsulation. That means pod is an encapsulation of containers, that storage, network, and sometimes we don't have only one container. Okay, but we can have multiple containers also we can have. So I'll tell. So whenever we use an EC2 instance, EC2 instance is having computing resources. Then from the EBS we are getting volume.
Storage,
Then VPC wise we are getting
network,
network. All that as an encapsulated unit we are calling as an EC2 instance. Now here in the pod also, pod is an encapsulation of one or more containers, their storage, network, managed as a single entity, we are calling as
pod,
pod. We are calling as pod. 90%, okay, so 90% we will have like one container itself, but sometimes there are some use cases. Okay, so there are some use cases why we'll go for multiple containers also. So why we'll go for multiple containers also we'll discuss. Okay. So mostly say we have the two containers. One is main container. Second one is called as sidecar. Okay. So main container and sidecar. But in some requirements, both the containers want to use the shared network and shared storage. At that moment, we'll go for multi-container pod, but 90% it would be single container, and each pod will get their own IP address. Okay, and will share the networking And volumes also can be mounted just like Docker we have. Here we have the PV and PVC. Just like in the Docker, we can start, stop like this. Here the pod lifecycle also we'll discuss. And pods are by default not permanent. Those would be creating, destroying. So we can control those from the higher level of objects than pod. Okay, those are called as pod controllers. So normally even in the Kubernetes also we have the service, right? Service will create more number of containers. On top of that we have the stacks. Like this on top of the pods here what we have is like we have the deployments, stateful sets, replica sets. Those we are going to discuss. And mostly we have single container pod. Single container pod we have. But there are some use cases we'll discuss in which scenario we'll go for a multi-container pod also. Okay, so you still practice more on the Docker and finish the Docker videos itself. But from the Kubernetes wise, everyone need to come with the Docker Swarm versus Kubernetes, Kubernetes architecture components, then what exactly the pod. Okay, so these all like 5 to 10 minutes. Everyone need to explain with your own words. Okay, if someone asks about the pod, what you will tell? If someone asks about the pod, what you will tell for that? The pod is the lowest level of object. Okay, so try to finish the Docker related itself. Docker Compose, Swarm, Docker file, multi-stage Docker file revise once again. Then Kubernetes architecture videos revise once again. Okay. Then I'll send one video for regarding how to spin up the Kubernetes cluster also. On premises, we should tell long back, but currently we are using managed services itself. Yeah, I'll share this in the WhatsApp. I'll send this document. Okay. So Kubernetes at least spend lot of time and lot of interest, then only we'll get the success. Okay.